Welcome to the series finale. Up until now, we've been flying this main ship, this Isolate. This is where your UI lives. This pilot is responsible for every button tap, every scroll, and every animation. In the last episode, we used a way to pause the pilot while waiting for data. But what if you need to do something heavy, like compressing a video or calculating a billion numbers? If you bring that heavy machinery into this cockpit, the ship becomes too heavy to steer. Your app stutters, frames drop, and users get angry. We can't do the heavy work here. This is how Dart solves the problem. We spawn a second ship, called a worker isolate. In Dart, these ships are completely isolated, which means there is no shared memory amongst them. This cargo ship has its own memory and its own event loop. It can grind its gears and overheat doing heavy math, and the pilot in the UI won't feel a thing. The UI stays buttery smooth because it physically cannot be blocked by this worker. So how do they talk? They talk using something called ports. Think of this as a laser link between the two different cockpits. The pilot sends a message, "Hey, here's a video, compress it." The cargo ship receives that message and starts compressing. It does the heavy lifting and shoots the results back. When it shoots the results back, the pilot can simply display the results without having to do any of the heavy math or the heavy work while seamlessly working with the UI the entire time. This is the only way that they interact. No shared variables, just messages. It's safer, cleaner, and crash-proof. Let me remove all of this code. In the old days, setting up these ships was hard. In modern Flutter, we have a magic button called Isolate.run. Follow this command. Let me start by creating a function that returns an integer called complex task. So inside complex task, inside the body, I want to create a variable called total, and I want to loop through this variable for var I equals to 0. So since var is 0 and about until 1 stands 100,000, 10,000, 100,000, million, 10 million, let's say 100 million times. And I want to increment I by only 1 every single time. And I want I to be added to my total every single instance of that loop. And in the end, I want to return my total. So if you're still unfamiliar with for loops, I'll go through it briefly. So for loop is just a type of loop. A loop is a block of code that repeats a statement over and over again until a specific condition is met. What we're doing is we're creating a variable called I and initializing it to the value 0. Our base condition is until the I reaches a value of 1,000,000, or as long as the value of I is under 1,000,000. After every instance, we're incrementing the value of I by 1. In every instance, we're adding the value of I to a variable called total. So in the first loop, the value of I is 0, and total plus equals to 0 is still 0. The next instance, the value of I will be 1, and the value of total will increase by 1. In the next instance, the value of total will increase by 2, then by 3, then by 4, and so forth until the value of I exceeds 1,000,000, upon which this condition will return false and our for loop will terminate. After our for loop terminates, it will return the value that is stored in total. Now, as you can probably guess, this is a very heavy task, and if we were to do multiple tasks like these in our front end directly, our app would be very laggy. Now, since we don't want that, we're using isolates. So inside our void main function, we put the keyword async to create an asynchronous function. We're just flying across the space smoothly. So this is what we're currently doing. Now imagine suddenly we need to calculate all of this complex task, which means we need to calculate numbers up to 1,000,000. So complex task calculation. For this, we simply just isolate run, which runs a ship. So final results So the result that we get from this, we're storing it into a variable called result, and we're creating a final variable. If you remember what final is, final basically makes this variable immutable after declaration. Equals to await, so we're waiting a response, we're waiting here until we get a response from this, Isolate.run, and the name of that function, complex task. Finally, we print UI ship received results, and we simply print the result. Since Dartpad does not actually support isolates because isolate is such a complex task management system, I'm using Android Studio to do the exact same thing. So it works exactly the same in the Dart programming language, but Dart Dev is just an online compiler and it has its limitations. So I'm running the exact same code in Android Studio. This works exactly the same how it would work in a production environment or a development environment on a live server or on a live application. So if I run this program now, ignore everything on the top here, but you can see that we're flying smoothly and the UI ship receives the results 1 million. With just that one line, isolate.run, Dart handled everything. It built the second ship, sent the task over using the laser link, waited for an answer, and then destroyed the ship to save battery. The pilot never stopped steering. So our main application never stopped running. It simply isolated this task so that it could run separately. After the task was complete, it deletes that environment, just stores the value that we receive from that, and then we can simply print that from our main UI. And there it is. You've completed the entire roadmap. You started knowing nothing. You learned how to store data in variables, make decisions with logic, build machines with functions, organize blueprints with classes, and finally architect parallel systems with isolates. You're no longer learning to code. You are now closer to thinking how a software engineer thinks. Now your final mission is just to take a break. Congratulations! And when you're ready, join me in the next series where we take all of this logic and start actually building a beautiful mobile application with Flutter.